nice to have you here uh, at this event of PClub. And we are all about open source. Lately, we are doing PClub Summer of Code. Basically, we are like giving people chance to work with repos that all the seniors are working on. So we really wanted people who are experienced with open source to to come by and let let the juniors know. So really, really, really nice to have you here.
Thank you. I appreciate it. I am looking forward to telling sort of my story of the various open source projects that I have been involved in, to at least show that it's very accessible to everybody. And I have a pretty long career in corporate and in other places, and I want to position where open source comes into the picture, and I hope to give some perspectives, just some stuff to talk about. And then in the last 15 minutes, maybe if it's been interesting enough, some people will have some questions, and we can have a little discussion.
Sure.
How many people do you usually get for the meetups, for the club meetings?
So it ranges from sometimes 20 to 50 people.
Okay, that's a good number. And Ashwani, do you program in Julia or?
Yeah, I program in Julia, Python both, and right now most of my work in the current lab that I am right now in is in Python, but for GSOC I'm doing work in Julia only.
What project are you working on?
So I'm working on an image processing project. So it adds like formats like JPEG and support for them basically
I think I read about that. You're wrapping some libraries, right? Some C libraries or something?
Yeah, C libraries.
That's cool. How do you want to do? Do you want to wait for some more people to drop in, or do you want me to start?
Yeah, we can wait a bit more. Till then, we can just have some informal discussion. So yeah. So speaking of Julia, he's the the beacon of Julia in our college. He has been advocating for Julia since I ever got into this college. And I think if people are coding in Julia now, it's all because of this guy.
That's cool. Yeah, I've also. Isn't that funny? Everybody that codes in Julia becomes an evangelist. It's not the same with Python, right? For some reason, people that program in Julia are very passionate about it, and I think that says something about it. There is something that's special that makes it.
The elegance.
Well, I'm not going to give away too much of it because I'm going to talk about this in a little bit. But yeah, good. Well, then we have something in common there as well.
Yeah, I think same goes for people who use Vim, because
that's funny. Yeah,
because I am just like him when it comes to Vim. I have got people to switch to Vim and new Vim, all that, and
that is so funny.
Yeah. So yeah,
I do some music on the side, and I'm making a music video for my current company, and it's a bit of a joke video about data science and stuff. And one of the lyrics is it's Vim for life, notebooks are a laugh. So I had to get that in the track there, just one for Vim as well. I didn't mention Julia, but I did say that Python is for children and postdocs.
That's smart. Yeah, I mean, I also do music on the side, but like I never got the chance to completely get into it because like things are quite hard here in India. Like you have to study for entrance exams and all. So now I'm like finally free. Finally, I'm gonna purchase a MIDI keyboard and finally get the music theory straight. Finally start again.
You sing anything?
I used to sing classical Indian music, but then I just stopped practicing. So yeah.
Indian music has a lot of cool microtonal stuff. I'm into very avant-garde things, and so everything that's weird weird, but non-typical Western pop harmony-wise is very fun for me. So I know Indian has a lot of microtonal harmonies that are pretty cool, but I'm not very good at it. But one thing that I think is so neat since I've been growing up in my lifetime is what computers can do for the individual, which is sort of democratize access to things that have been prohibitively expensive in the past. So, it is cool to have a keyboard, granted, but the fact that if you do have a keyboard, and even if you don't have a keyboard, you can make really good sounding music in your home with just a laptop and by watching YouTube. I think that's pretty magical, that anybody can learn anything online. I think that's wow, what a gift to humanity.
True. That is indeed true, because that is how I learned to. I just had some, tune in my mind, and I was like, you know what, I have to get this down. And I searched up how to use Ableton, how to use Logic Pro, and bam, that's how I got started. So.
Yeah. Well, I've been I've been wanting to mix AI, and AI is what I work with. Otherwise, I've been wanting to mix AI with music for a while, but I have too many projects that it's gotten far down on the list, along with playing video games and other stuff that I really want to do. But I'll get there eventually.
Yeah, we all have those ideas that what we want to do it. It's fun and all.
You have to do some of them, though. You can't just start like 20 projects and never finish any of them. Some of them you have to finish sometimes.
True.
Yeah, just pick like even just one project and make sure you do it really good. I'm going to talk about career a little bit at the end, because I've been very lucky, but sort of like you can set yourself up to avoid bad luck by you can maybe avoid a fire in your house by putting up a fire alarm. So you do something to avoid bad luck. You can do stuff to give yourself more good luck as well. And so even though I have been very lucky, I think many of the things I've done have sort of helped me get a lot of good stuff. And so I'm thinking I want to trade some of those career luck creating advices today. Wow, it looks like people are dropping in. That's cool.
Yeah. See, that would be really nice.
Face to face, or is it mostly online?
We do both, but recently we have been very comfortable with the whole online thing because of COVID. So like nowadays we are seeing more active participation in online meets. So you know what, we went with the hybrid approach. So yeah. So what you said about all those mechanisms to, make sure that you get more luck, that sounds like, a heck of an insight that we would be, lucky to. Yeah. So
I'd be glad to talk about that. And it's going to be hard for me to remember everything that I want to go through. I was thinking now also just working on projects without ever meeting people is how open source has been done in the past. So for people that have been working on open source for a long time, COVID isn't really a new thing. And now everybody else is super shocked. How can we be effective if we don't meet each other? And it's like, this is what we've been doing. It works. It's produced some of the best software in the world even. So it's not, it's not a strange thing. But I've noticed from my own part, I'm not a very social person. I enjoy meeting people in real life once a week, maybe. But even I miss meeting people now during COVID. After not seeing people for like months in a row, I sort of want to meet just one person, just hang out for an afternoon. And then, so I think everybody has suffered a little bit from having to break from their ordinary habits.
I think we can start. Can you mute?
Okay. I usually am pretty cognizant of time. So what do you say about we go to 2:50 with the presentation and then open up for questions afterwards? Is that all right?
Yeah. So let me take
2:50, your time is.
Let me take the opportunity to introduce Robert for you guys. So Robert is an AI and data science advisor, and he did his bachelor's from Chalmers University of Technology, Gothenburg, Sweden, in algorithms and formal logic. And he has been in multiple roles related to machine learning and high performance computing over the years. And he has also passion for entrepreneurship and art, as we were discussing before. So in this particular event, we are we're going to be discussing. Robert is going to be discussing about how you can start in open source, a basic pathway basically, and his journey in it. Yeah, good to have you,
Excellent.
Robert.
Thank you, Ashwani. I appreciate the introduction, and thank you everybody for having me. I'm not going to show slides because slides in almost all cases are fairly boring, and also I want this to be clear that what I'm sharing now are my experiences, and they're real experiences, and I want you all to feel like the same opportunities that were afforded me can happen to you very quickly. And I believe that in the case of open source. So I'm going to start by telling you my story, and I'm going to weave in a lot of things. And I encourage you, if you have a question, if you want me to expand on the details or something, or if you have a question, to please write them in the chat or even interrupt and ask me straight away so I can expand on it, because there's so many things that have happened that I'm going to have a hard time remembering all of it. So like you heard, I studied at university computer science, but this whole story started a long time before that. I studied at university 15 years ago. So let's go back to, I want to tell the story because it all fits together, and I hope to sort of kindle a passion that perhaps many of you already have, but at least sort of inspire you further, especially if you recognize yourselves in this. My journey with computers started when I was quite young, and my dad let me build a computer together with him that he was going to use for his office work, and I got to sit next to him and watch when he put in a sound card and put in some other stuff, quad speed CD-ROM and that kind of thing. But I was never good at computers, and I was never disciplined in school, and I was not especially disciplined in university either, for that matter, but we'll get to that in just a bit. My first experience with open source, if you will, was in high school when we were asked, and this was in 1997 or 98 maybe, and they asked me to create a user account on the school network. And so we walked up to the IT administrator, and back then things weren't quite as sophisticated. So there was always one nerdy guy that was in charge of all the computers at the school. So, we walked up to this guy's computer and he said, here's your username. It's your first initial and your last name. Type in your password that you want. And he gave us instruction on how to choose a good password. And it was a black screen with a prompt on it. And I had never seen anything like it because my only experience with computers was with Windows. Windows 95 had just come out a little bit earlier, and I thought the prompt looked cool. And I was like, what is this? And he was like, it's Linux. And I was like, okay, what does that mean? And it's like, it's another system than Windows. It's different. And I was like, okay, cool, but why don't you run Windows? And he's like, because Linux is better. And I'm like, oh yeah? Well, if it's so good, why doesn't everybody run Linux? And he's like, because you have to be smart to run Linux. And I was like, oh, my mind exploded. And I was like, I have to go home and I want Linux. So there was nothing. I mean, we didn't have internet. We had internet with a modem, but I couldn't go and find stuff. I was too young. I didn't know how that stuff worked. And I went to the store at Barnes & Noble's, and it was the most gigantic Barnes & Noble's ever. This was in the United States. And so there was a Linux magazine. And bundled with the Linux magazine was a CD with Red Hat Linux. And I brought the CD home, and I installed it on our home computer, and I ruined everything. And so my dad and my mom were very upset at me, but that's how it started anyway. Fast forward maybe 2 or 3 years, and we moved to Sweden, where I am now. And at that time, I was a teenager. I was 15. And I got a job at a hot dog stand, and I worked there for 4 months. And I saved all the money that I had gotten at that hot dog stand, and I bought my own computer. And I installed Gentoo Linux on it. And I felt like a hacker from the movies, basically, when I was running that stuff. And I found some friends in Sweden that were also running Linux. I guess I had nothing else to talk about. I'm not even sure how I found them because I was, I had nothing else to talk about. And then I was, oh, you also run Linux? Yeah. I guess that's what you talk about when you meet people. Do you run Gentoo Linux? I don't know. So we managed to find each other, and we hung out on what was called IRC, which is basically like Slack but much uglier in a terminal, and it was full of security holes and everything. And I asked. Linux was very hard then because GNOME was really bad. Nothing worked. The drivers didn't work. The file system was buggy. It was just a sort of. It was for sadists that really wanted to do everything the hard way, and that's like how it started for me. I started with I want to do it the hard way because it's cool, and I asked my friends, how do I install a package? And I was actually not using Gentoo. I was using Slackware at that time. And Slack had this thing where you got a tarball, a TGZ file, and you had to install the package that way. And I think one of the packages had a message like to configure this program, you need to edit a file. And here's the file. And I was on IRC and I was like, how do I edit the file to my friends? And they're like, just use Vim. And I was like, okay. And I typed Vim in the file. I'm like, oh, cool, here it is. And nothing worked. I couldn't edit the file. I couldn't exit Vim. And I just had to reboot the computer because I couldn't figure out how to get out of Vim. And we know now from Stack Overflow that how to exit Vim is the most popular computer question of all time. But at that time, I wrote on IRC, I'm like, you idiots, you tricked me into going into Vim and you didn't tell me how to get out. And they're like, lol, 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 you're so stupid. You didn't know how to exit Vim. And I was like, oh my gosh, you bastards. I am not going to use Linux anymore. And I went online and I'm like, what's better than Linux? And BSD came up, BSD Unix. So I was like, cool, I'm going to start using FreeBSD instead. It's much better than Linux for even smarter people. And the funny thing is, the joke is Linux is for people that hate Microsoft and BSD is for people that love Unix. But so this was like right before 2000s. And at that time, open source was basically GNU and BSD. And the community was so small that people knew each other. So when I started with FreeBSD, there was like a team of 40 people hanging out on IRC, building this operating system that was powering some of the biggest services, I mean, biggest at the time on the internet, but Hotmail, the precursor to Outlook, Hotmail was bought by Microsoft, was running on FreeBSD at the time and was running on FreeBSD for a long time after Microsoft bought them. And so I was on FreeBSD, and there was this one guy called Matt Dillon that had these ideas about how to make an operating system. And he was so fast at programming, they would be discussing something, and they would say, I think we should try this. And he'd be like, cool. And he would come back the next day and had implemented it the way he thought it should be implemented. And people were just not fast enough to program stuff and keep up with him. So, when he committed something, it would get committed because he was the one that made it, because he was so fast. And at some point, people got annoyed at him because his code was always getting committed. And they were like, no, we can't do this. And he was like, you know what? I'm going to make my own operating system, Dragonfly BSD. And I hopped onto that bandwagon. And this was about 2003. And the reason I'm saying this is because there's a couple of things that are interesting about operating systems. Operating systems, compared to, say, programming languages or databases or anything like that, are meant to serve a general purpose user. It's very pure computer science. It's very much about understanding edge cases, avoiding race conditions. The big thing in 2003 was that it was obvious from Intel and the others that multi-core was going to be a thing. And although operating systems had concurrent abilities for a long time, they didn't have parallel abilities. So, it was possible to run many programs at the same time, but it wasn't actually, no, I should specify. Concurrency means running things without a predefined order. Parallelism means running things at the same time. And there are slightly different bugs for the two different abstractions. Now we tend to think of concurrency and parallelism as the same thing because in practice they are. But back then you would have an operating system that could run stuff concurrently, meaning you can run two programs at once, which you couldn't do in DOS. But you couldn't run two programs on two processors at the same time, for example, or one program on two processors at the same time. In any case, operating systems are trying to solve a very general case of problems. And solving the general problem is much harder than solving the specific problem. So, you have languages now like Erlang from Ericsson, which is really good for highly distributed, purely CPU bound things like telephone calls and embarrassingly parallel data, but are not as good for actual IO intensive workloads or non-cache coherent workloads. Operating systems are more pure and cooler because they have to solve the general case. Okay, so for me at that time, I was thinking the epitome, and I was very obsessed with being the best at everything. The epitome of hackerdom and knowing everything is making the ultimate operating system. And so because it was 40 people hanging out on IRC, and when Matt Dillon hopped off, it was like 8 people. We all sort of chatted with each other and knew each other. And at that time, we weren't using Git. We were using CSV or CSV, I think it was called. And we were the first ones to switch to Git long before FreeBSD and the others switched to Git. But that was when I started understanding that it's just a bunch of people and we're hanging out and having fun, and we can actually work on something that before to me was ethereal. It was just given. It's like music. Back in the 90s and early 2000s, rock stars were like these gods that existed out in the ether. They weren't real people. They were just like images. And now with social media, you can almost reach out and touch a person and talk to them and whatever. It's the same with open source. You might think that Microsoft Windows is this behemoth that it doesn't really exist in real life and it's just provided. But open source is a little bit different because Windows isn't like that. But open source makes it very apparent that you can be a part of that system. So for me, with Dragonfly BSD, I started working on multi-threading stuff. And at first, I was just contributing to discussions, benchmarking. Matt would push out a patch and say, does this fix something? And I would test it and we would go back and forth. And I sort of felt like the team, and I was contributing. Not everybody that works on open source has to do programming because I wasn't good at C at the time. I was helping out with articles. I was filling out, the website. I was doing the benchmarks that they wanted, testing on my hardware and so on. And then one summer, Google started the Google Summer of Code. I think this was 2004, 2005, something like that. And they would pay a little bit of money for you to work on open source during the summer. And Dragonfly made it in, and I worked on some threading stuff that never ended up being committed, but ended up being rewritten by people that were much better than me. But in any case, that was my first touch with open source, and I thought it was pretty fun, and it allowed me to be sort of a member of a community and get some of my stuff committed. I think I'm credited with the only thing I'm credited with on the Dragonfly BSD website right now is for making their logo. I didn't actually make the logo. Some guy called Joe made the logo, but he had made some mistakes with the vector graphics, and so I sat and fixed that up. So the version of the logo that you'll find there is the one that I made. But my point is, there's many ways into open source, and you don't have to be like an expert coder to begin with. There are some people that are super valuable in the community that never code, and they can start that way. So that's one thing that's worth knowing, that an open source project is more than just the core committers. It's a community. Okay, so what is the context in 2004, right? 95 to 2000, it's scrappy hackers. At this time, Google had started becoming like a behemoth, and they were positioning themselves against Microsoft as being the good guy. And I had been at university for a couple of years studying pure computer science. I was not very good at university. I did my master's thesis on threading systems in the kernel, and I never got enough points to get my degree. So I don't have a degree, even though I did the master's program and all the courses and everything. And I was very adamant, because I had only become good at C and assembly, that I didn't want to learn JavaScript or Python or anything like that, because I thought they weren't as good as the pure C and assembly and general case thing. I thought all those languages were basically lame versions of C. And I guess I was wrong to a large degree. I'll just let's just put a pin in that one for a while. We'll get back to languages. But Google was basically the dream place to end up, and we're really piggybacking on open source. I think they realized very early that if they had become dependent on Microsoft, it would have cost them too much. So they started running Linux and having that as a point of differentiation. And I knew that they had hired so many engineers that were good enough that they were writing custom kernels for their Linux distribution. But the weird thing was they weren't committing it back upstream. So the Linux project was never getting any of the benefits of, Google had these cool distributed file systems and a whole bunch of stuff, the stuff that eventually ended up becoming Hadoop. And nobody ever got to see any of it. And I was already at that time skeptical. I'm like, what kind of a practice is this? But okay, we'll see. I ended up at Microsoft, and there I was sort of called a traitor for being the BSD guy that went over to the dark side of Microsoft. And it turned out all the companies like Apple, Microsoft, Google, and everybody are actually all much more similar than you would imagine. They're all giant machines, and they don't have personalities. They're not good or evil. They're just chewing through stuff automatically. So you can't blame and say that they have personalities. They don't do things for good or evil. They're just automatons that move forward in the direction they're headed. And you can sort of slightly steer the ship when you're the CEO, but that's basically it. You're just a cog in a machine there. But at that time, Hadoop started becoming a thing. So Google never released their code. They still haven't released their code. And there are open source versions of these distributed file systems. And the thing that you noticed in terms of what works and what doesn't work in open source is there are some companies that make use of open source. And this is a business model thing that you can just be aware of when you start a company, when you join a company, or when you're trying to determine, is this thing future-proof? There's two ways that companies use open source. One is they use open source and they don't commit back if they make changes. And the other one is that they use open source and they add features, but those are behind a paywall. So I'm going to give a couple of examples of companies that do this differently. For example, right now, Amazon is a very bad guy in that sense. They use MXNet, they use Postgres, they use all this cool open source software and never commit anything back. Then there's other companies like Cloudera where the stuff is open source, but their value proposition is Cloudera Manager and other stuff. Okay, so for those that don't know, Cloudera is a company that bundles Hadoop, which is a big data platform, which is managed by Apache and is open source. But Cloudera has these cool management tools, these graphical interfaces that make it pleasant to use an otherwise really annoying Java experience. And that stuff costs money. So anybody that wants to play around with Cloudera gets the garbage experience. And if you want to get the pleasant experience, you have to pay. Contrast that, for example, with some other companies like Databricks that work with Spark. Spark and everything that Databricks makes is open source, but what they charge for are value-added services. So they have services that they sell to enterprises that are very valuable. So the product itself, the open source piece, is truly open source. The entire thing is open source, and the company makes money through services. That model seems to be the one that sort of stands the test of time. The one where companies either keep things a secret or they try to make one part proprietary, the good part, basically, and then just piggyback off open source. That one doesn't seem to stand the test of time as well. So we'll see how it goes for Amazon and the others. But let's go back then now to where we were in this journey here. After university, during university, I was lucky enough to meet a woman that I ended up marrying, but she got a job at Microsoft because she had really good grades and she was just really, really good at school. And she introduced me to a person at Microsoft. Otherwise, I probably never would have gotten my foot in the door. And let's talk about luck for just a second here. I got my foot in at the door at Microsoft, and because I had done Google Summer of Code and I had actually been involved in open source conferences and a lot of things like that, they were like, okay, this guy sticks out because everybody else just has good grades on their coursework, but they're all sort of clones of each other. There's nothing to make them stand out. Whereas I had tons of summer activities, volunteer activities. I was member of, the school network. I was an administrator for the schools network, stuff like that. So I had like 15 things on my CV. It wasn't like big stuff, but I mean, you're not comparing to a pro, you're comparing to other students. And so in that regard, I stuck out a lot. And so the Microsoft guys were like, okay, you seem like a good guy. You seem like you stick out a bit. We'll give you a chance. And I was like, oh, thank you, God, because there was no way I was ever going to get my degree and I didn't have super great grades. So let's talk about luck for just a second here. I was talking to Shadabarto, was that good? Earlier about luck. And a lot of people dismiss luck and the role, no, not dismiss luck, but dismiss how much control you have over the luck in your career. So I'll give you one example why people are fooled by luck playing a bigger part than it actually plays. Imagine you want to apply to NASA. You want to become an astronaut and go out into space. Okay, so there's 1,000 people applying to NASA and there's only 10 spots. And let's say, NASA sorts through the people and picks the 10 best people. And then you look at what contributed to them picking those 10 best people. Let's just say that 5% of what contributed to them being picked was just pure luck. Somebody threw a die and those people got that much luck on their CV. And so that contributed to their total attractiveness being picked by NASA. Some people conclude and say, well, if you take away the luck, then none of those 10 people would be there because the people that are next in line, they would be picked instead. The fact is that the first 100 people in line have really good and similar qualifications in every respect. And so it's sort of a coin toss who makes it in. The only difference being the last sliver of luck at the very top. So it's not like the people that make it into NASA are unqualified, these 10 people. It's just that when you have 100 people that are exactly the same, the only thing that makes a difference is that small sliver of luck. Okay, so what can you do to affect that luck? I think some people feel like, well, luck is luck. You can't do anything about it. But you do accept that you can affect your bad luck. For example, you don't run across the street with your eyes closed. That's very unlucky. You have a fire alarm in your house maybe to avoid fires. That would be bad luck. So you're trying to avoid bad luck by doing things. You can also do things to bring yourself good luck. For example, a contact of yours might be able to get you a good job. Well, how do you make yourself lucky enough to have a good contact? You got to meet people. You got to shake hands. You have to be charming. You have to smell good. You know what I'm saying? All that stuff plays a part in the luck that you build for yourself. It's not a guarantee for you getting that contact. I guess that's what makes it luck. But you can control a lot of the circumstances that create, if 1 in 20 people might be a good contact, what can you do to guarantee that you meet a contact? Well, you have to meet at least 20 people. You need to meet 40 people. If you just meet one person, chances are that's not going to be the contact that gets you the good job. So in that sense, I think luck is something you can make serve to your advantage. Okay, so I was very lucky and I got into Microsoft. And at that point, I worked there for 5 years in technical pre-sales, and that's when I sort of got a taste for AI. And I started programming in R and Python a little bit. unwillingly, because Microsoft had APIs for their AI stuff in R and Python, and I used R because I heard mathy people liked it more, so I didn't want to use Python. Hold on. And um, so I quit Microsoft because they thought that databases were a big deal then, and AI wasn't going to be a big deal yet. At least in my subsidiary in Sweden, we were just a sales organization, and I started working in telecom at Tele2. And I became the manager of new growth, which means my responsibility was to create new business and come up with stuff that could make the company money. And so the first thing I said was, well, we need to know our customers. We need to have data. What can we do? And they're like, well, we have a big Oracle database, but you're not getting access to it. And I'm like, all right, cool. I had my own budget. I was like, I'll pick a couple of old servers that aren't being used for anything, and I'll run some stuff on it. And I started learning about Hadoop, which was open source at the time, and I installed Hadoop on it. And Hadoop was very hard to use, which is why it probably wasn't being used by many people. And Cloudera was really making headway because their tool was so compelling. But I got into political problems. What I mean by that is there was an Oracle database at the telecom operator that they had spent billions of monies building. And along I come and have these scrappy servers that make everybody look bad, right? So a query that would take 20 minutes on the Oracle machine would take 2 seconds on the Cloudera cluster that I put together. And they did not like that. So there was a big argument, you're making us look bad, and so on. But the fun part was that that sort of cemented me as a bit of an expert in those tools. And there was a big sort of shift then when people were saying, can we trust open source tools to run critical stuff? And people were very ignorant of this because this is before. Now people know that going data driven is a thing, but people didn't think of themselves as software companies then. I'll just give one example. Right now I'm working with a company that is filled with ecologists, like biologists. They go out into the forest and they say, this forest is worth this much because it has 3 different species of blah, blah, blah. And they sort of make an inventory of the forest. And they've been doing that for 20 years. And so now they have a big data set, and if they want to do twice as much business and save the world twice as much by cataloging stuff, they have to hire twice as many biologists. And that's not scalable. So they're like, oh, how can we go data driven? How can we use the data we have? And how can we turn this into a service? And I'm helping them with that. But they hadn't thought of themselves as a data company or a software company. They thought of themselves as a biology consulting company. And that was very shocking to them. And this is now. And I think a lot of companies are going through that journey right now, understanding that data and decision making is central to the services that they offer. But 6 or 7 years ago, this wasn't quite as evident. And people didn't understand the role that computers had in their processes. So even though they were using Linux and other open source stuff, Linux wasn't really something that a business user even knew what it was. What they did know was that Oracle did the sales predictions. Oracle did all the important stuff. Nobody ever got fired for buying Oracle. Nobody ever got fired for buying IBM. So for me to come and say, oh, no, there's this thing that's for free out on the internet and you can download it and put it there. And they're like, cool, who's going to manage it? There's a small startup in Silicon Valley called Cloudera, and they can help us with that. They're like, that doesn't sound legit. Well, this is what I work with now is this sort of agile methodology on why it is legit. We can get into that later if you're interested. But the point is, there was a very big mistrust of using open source software for enterprisey stuff. Okay, so moving on. At that point, Spark was just a new thing, and it was spanking everything in terms of performance. But I wanted to program stuff manually. And
Man, programming stuff from scratch in C is a slog, no matter how you put it. Because when you work with operating systems, stuff is already written and you're just improving it a lot of times. And a lot of times you're just writing pure algorithms that are very like mathy like, trying to manipulate data structures. You're not actually writing like programs that people are supposed to use. And so writing stuff in C is a big hassle. And I was looking up like what language I could use, and I came across Julia. And Julia is a programming language that looks like MATLAB. So the syntax is very amenable to mathy stuff compared to Python, where you have, matrix dot transpose dot some subfunction dot send to dot numpy dot whatever. It just doesn't look good. It doesn't look like math. So Julia has the MATLAB like really nice syntax. It has the dynamic typing of Python. It has the speed of C because it's JITted. So it's like using Numba all the time. And it's just convenient. So all of a sudden I started using Julia and I felt like a god because I was productive like a Python person, but I still had the control that the C person wanted. And at that time, Julia was a small community that, again, it was like, I wasn't 40 people, but I guess the core community was like 40, 80 people, something like that. And now they were hanging out on Slack instead of IRC, but it was basically the same thing. And, this mentality that I had from the beginning of doing things the hard way, I'm a little bit cynical when people ask me, what is the key to success? I'm a little bit cynical because, if you know, and if you don't know, you can't be told. So what I want to do here is some of you will look at a project like Julia and be like, what the hell? There's no documentation. None of this stuff Python is so mature. There's nothing here in Julia. It's empty. How is this a machine learning framework? It's just arrays. What am I supposed to do with an array? Give me a tensor board or something like that with a graphical interface. And some people, when they see that, they're like, all right, let's do this. And I can't change that part. But what I can say is for those of you that get really excited by the idea of you playing an important role, this stuff is just ripe for the picking. So let me give an example in machine learning right now with Julia. In Julia, there is this framework for machine learning called Flux. And Flux started out as just a program. Actually, can I ask you, is everybody in this call a little bit familiar with machine learning or mathy stuff, or is it very varied?
Most of them are from second year, so yeah, I think we can discuss it because
Okay,
they have
I'll
discussed like basic linear algebra and different.
Good. I'll keep it basic like that then. So Flux was initially just so Julia is really nice because the way Julia works is it's like Lisp, and before it's JITted, so it's compiled when you need to compile it, and the language is not like C. C has a preprocessor where it preprocesses the file and then it turns it into the code. Julia syntax is so strict that it turns it into an abstract syntax tree. If you guys study compiler design, and then it can rewrite the syntax tree, which is called metaprogramming. So Lisp can rewrite itself. Julia can rewrite itself. It has macros like that. And the cool part is that if the syntax is descriptive enough that the compiler can know what's going on, it can help you out and do things. And one of the first things we asked the compiler to do was to track gradients. So if you want to calculate the derivative of something, you ask the compiler to do that for you. So the first package, Flux, was a machine learning framework, but it didn't really do anything. The only thing it did was track gradients. And so there were already machine learning frameworks like MXNet, which is now owned by Amazon. And if you ask me, it's dead. Nobody wants it anymore because Amazon did the same thing. They took it, they did a bunch of cool stuff, and then they never gave anything back. But Flux Julia has really good arrays out of the box, unlike Python. I don't even know how you can call yourself a programming language and not have support for arrays. In any case, Julia has really good support for arrays out of the box. It's fast. You don't have to vectorize. It just works. And so Flux comes and tracks the gradients. So you stack two arrays on top of each other. You have a little activation function and you do some nice multiplication between them. Boom, you have a neural network. If you track the gradients, you can propagate the error backwards and you have a deep learning neural network that just works. Now, this is super raw. There's no documentation for anything. I mean, the documentation is the code. And that's the thing. The code is, I don't know. I mean, Ashwani, you've been working with Julia, but when I bring some people on board in my companies, and we've been using Julia now for like 6 years, they're like, where do I find the Medium articles? And I'm like, you don't find the Medium articles. You go to GitHub and you read the stuff.
So it's like always go for the doc strings, and yeah, of course, it's mostly the doc strings for me or the issues. Or for standard modules, you have to go back to the documentation. Like the base documentation is very good.
Yeah. And another thing that people have complained about are that the error messages are no good. Maybe because the error messages in C are, you screwed up about here. Good luck, have fun. So maybe I'm just not picky. Like maybe in Python, the error messages are super nice. I'm actually quite good at Python now, unwillingly, because all the banks make me do Python. And the more I learn about Python, the more I hate it. But in Julia, it basically tells you where the error is, what the type that if there was a typecasting error and some stuff like that. But the appeal of working in open source isn't necessarily that it's a job that you get credit for. I think I'm gonna tie this into, because we have 5 minutes left and I want to start opening up for questions. I want to tie this into where this is leading for you guys. I told you that my last job was at the telecom company. 1 year after I was at the telecom company, I started consulting. I started my own company. And since then, I've started many companies, product companies and consulting companies. And right now I'm at a consulting company that does what we call executive advisory services. So basically, I just talk with a bunch of old people that trust me, because I do know how to program CUDA kernels, but I also know how to make a project actually make it to the finish line. And oh man, this is the best time of my life, because I was lied to growing up, saying that the point of your life is to have a career. And maybe it's different in different parts of the world, the harsh realities of what you have to and don't have to do. But I still think to a certain degree this advice can be applicable to anybody. And that is, if you aim for a specific outcome, it's very unlikely that you're going to achieve that outcome, because circumstances and you're not wise enough to what it is that's actually necessary to get to that exact point. And then once you've gotten that experience, you're like, oh man, I would have done things differently because I didn't know this thing then. And if I had known it then I knew that it wouldn't have worked out, and so on. Instead, what you should be focusing on, instead of getting a job that has the word manager in it, instead of getting a job that has the word senior in it, you should be focusing on being really damn good at something. Because what is value? Value is when people say that the stuff you do is worth something somewhere. And if you're doing stuff that is worth something to someone, people are going to want you. They're going to be like, oh, I want this guy. He's always doing good stuff. I want him on my team. I don't want to be his enemy. I don't want him on the enemy team. I want to hire him. I want to work with him, or I want him to be my boss because his teams always finish the projects, whatever. My advice is you're going to make a career, sure, but your career should be being really good at whatever it is you're doing. So not many things, but just one thing. And for me, I didn't plan all the open source projects that I've been working on. For example, I have a couple of things on GitHub that are public. One of them that I'm a little bit proud of, it's silly, but it's this object detector thing in Julia. I made a pure Julia implementation of YOLO because I was making I wanted to fit a real-time image object detector on the little NVIDIA Jetson. And they're so small that the garbage collection is a big issue. And I just spent a long time figuring out how to make this really, really elegant thing. And the funny thing was when I put it up and I announced it in the channel, I hadn't planned on sharing it, but the code and the doc strings and everything were nice enough that the people that looked at it just sort of got it by reading it. And I had that as an ambition. I wanted it to look good, and I was proud of it. There was this one thing at Microsoft that I've always carried with me, and Microsoft has let it go since a long time. But there was this one time when Microsoft released Windows 8, and they had the principles of design. The principles were like typography, authentically digital. You know, because when Apple had the book app on the phone, it was like a fake bookshelf, and it's like, why are you faking a bookshelf? You're on a phone. Do something that's authentically digital. Anyway, one of the principles that Microsoft had then was pride and craftsmanship. You should be doing stuff that you're proud of. That when you say, well, it didn't, maybe I didn't get rich off this, but man, this I did a good job. This is something I did a good job with this. Don't just leave crap behind. If you just have that mindset, the career will take care of itself by itself, and you'll end up doing good things. And I think open source, just to wrap up the story about open source here, there's many ways to get involved in open source. You don't have to start coding immediately. It's a lot about community. It's about finding something that interests you in particular. This is not about cheating and making a career. It's about being good at something. It's about doing something that you're interested in. Find the stuff that you're interested in. That, like me, when I saw the prompt, I felt like freaking Gandalf when I started learning the commands. Like computers are literally rocks that we can control and tell them what to do by sending in magic commands, and they start doing that's pretty magic. It's still cool to me, I think, and AI is even more like that. So find the stuff that you like, whether it's images, biology, or whatever, and work a little bit with it, and that's going to end up being a star, sort of a badge of honor that you carry with you. And you'll find that if you don't do it for the thing's sake, but you do it to be good, it will help you out in the future. And Julia is one thing that I recommend, but it doesn't have to be any of those. There's lots of open source projects that you can be involved in. Conferences, online, on GitHub, and other places. So that's basically it. I think we should open up for questions.
Yeah, do you guys have any questions?
Yeah, feel free to ask if anyone does have questions.
I can't quite hear.
I don't. Wait. So I have few questions of mine.
Yeah, let's go with that.
So you were talking about how you have worked with CUDA and all, and recently NVIDIA open sourced their few of their kernels. So like, how has Julia community reacted to it, and what is your emotions about it?
Yeah, good question. So there's the GPU channels on Slack and stuff, and NVIDIA has released kernel modules that are open source. So the drivers aren't open source, and importantly, CUDA, Vulkan, and the other stuff's not open source either. The good news, I suppose, is that Julia is the first. We immediately committed fixes to the modules. Julia programmer was the first person to do a pull request to NVIDIA to add features to their Linux modules, and so now the open source modules are have more features than the proprietary ones. So you see, the power of open source is there are two kinds of softwares. Android is a great example of a crappy open source project where it's not really open source. People don't commit stuff back to Google, and it doesn't end up getting improved. And it's the same thing with Chrome. You need a company like Microsoft that can just almost fork the entire project on its own. And even them are having a hard time sort of collaborating with Google and getting stuff pushed upstream. So maybe this is, the Julia people are carefully optimistic. And we just hope that this is a trend that NVIDIA will sort of continue slowly. I think it's hard to make everything super open source. And that's why everybody, wants AMD to succeed, because they feel like they can't compete purely with NVIDIA right now. So they're trying to compete and get the open source community to rally around them. But right now, there's nothing comparable to CUDA, unfortunately. So, but I know a lot of people at NVIDIA, and they're not sitting around resting either. It's not fun to root for the company that's the best if they don't have competition. And I feel like NVIDIA right now doesn't really have competition in some of those areas. But I do think NVIDIA is taking the threat of being outrun seriously. So hopefully this is just a sign of them going more open source and reaping the benefits of that model of software development. There was a question here I saw. Let me see. I want to get to the one in the chat because I want people to be encouraged to ask questions. Somebody beginning their journey, something wish you'd known when you began first. Okay. Is pre-final year a good year to be looking into big projects? Okay, let's answer both of those questions. One of the things that I think is important in open source is being a good communicator. I want to encourage everybody to be very verbal and very polite. Ask a lot, write a lot, and don't and be very polite. It's very easy to misunderstand stuff on the web, and this is a great opportunity for you to. So my sister and I started with open source at the same time. She works at Google now, and we had very different personalities. If something didn't work for me, I would just ask on IRC, whereas she would feel stupid for asking. Oh, I don't want to bother them. People are friendly and they want to help each other out as long as you're respectful of them. So you have to hit a little bit of a sweet balance where you're not asking people to do work for you, but so that has to do with you being involved in the community and seeing what are other people talking about. Did you search for your problem first to see if there were anybody else that had the same problems? But then sort of, don't be afraid to ask. Don't be afraid to write stuff. And don't be afraid to, if you think you're a crappy programmer, don't think so. Many, many times it's good to do a pull request and get the feedback and rewrite it. Or there's many times when people have done a pull request and nobody even used the original pull request, but it spurred sort of like a chain of reactions that resulted in something really good. So this is actually something that applies in the corporate world as well. It's better to start and do wrong and redo it and do it well than to try and do something perfect from the beginning. Because every time you do something wrong, you actually get better, and the second version becomes better. The third sort of fast iteration will always be better than your sort of ultimate plan that you're trying to make and follow through on. So be polite, be very verbal. I mean, write a lot, communicate with. You need to get really good at communication. That's one of the keys. I don't know if you notice now, I do presentations a lot. I didn't actually prepare for this presentation. Maybe you can tell, but you need to be really good at communication. I think that's something that I would urge you all to consciously practice, becoming good at communication. Pre-final year. So I guess that's the 2 years before you graduate, looking into big projects. I don't think you don't have to wait for any year to get into a big or a small project. I don't think you should be thinking of it in terms of big or small projects. There are small libraries that are super important. I mean, take like a tiny piece of, it's not tiny, it's actually quite big, but I was going to give the example of basic linear algebra libraries that are critical for lots of other projects. That might just seem like a small project that nobody is interested in, that like, who cares about BLAS software? If I were a hiring manager and I was looking for a programmer and I saw somebody had committed stuff to a BLAS library in Fortran or in Julia, man, I would be super impressed. It has nothing to do with how big the project is or how prestigious it is. It has to do with how good your work is. Again, so this circles back to make sure you're doing a good job. You can't coattail on a project. You want it to be that people want to be associated with you. You can't piggyback off other stuff. So I think that's the mindset you should be having.
I have a question about Julia, and I apologize for the noise in the background. I'm in a bus right now. But from the talk, like Julia really seemed like an interesting language. But I'm more of a static typing guy. I love Rust. I love Haskell, and I really have a strong opinion. But I recently got into machine learning. Before I was into operating systems, Linux and Android. Recently into cryptography as well. But I, just got into machine learning, and I didn't like Python, at least for machine learning, right? I think Python still has other uses, but I didn't like it for machine learning. Uh, do you think I'd find Julia much more pleasant, much more better for the machine learning at least?
Yes, let me tell you why. So, Rust, cool language. I love it, especially for embedded systems, systems programming, hardcore applications like databases. Cool stuff. Haskell, maybe for CPU bound stuff and for some very mathy stuff. The thing I don't like about Haskell is because it's so strict in its functional paradigm, there are some algorithms that are just better expressed iteratively. And forcing a person to express an algorithm that's iterative in a functional way, or vice versa, having to only write something iterative that would be better expressed functionally and having a performance penalty one way, or maybe just that it becomes super clumpy to express it that way, hard to read, I think is very annoying. But Julia, the type situation with Julia is you can be super strict about typing and you'll get all the performance benefits. So one of the first problems that Julia beginners have is because Julia doesn't require you to type your stuff strictly is they'll say, oh, this stuff is running slow, and it's because of type instability. And then as soon as you start casting stuff and being explicit with your types, they get like a 30x performance boost or something like that. From that perspective, I think you'll enjoy it. The second thing is when it comes to machine learning, I'm friends with a lot of people at DeepMind and some other places, and they're all using JAX and that kind of stuff. But if you really want to be at like the bleeding edge of ML research, so if you want to be on the bleeding edge of applied ML, Python is probably better because there's just a lot of stuff that comes out of the box that'll let you focus on doing some experiments. That being said, if you want to be on the bleeding edge of ML research, so for example, advanced compiler optimization of gradient tracking, geometric deep learning, physics-inspired neural networks, and that kind of thing, Julia is a great place to be because the community is quite large. They're all publishing a bunch of stuff, and for that kind of stuff, you don't need all the pre-baked things. It really is just primitives and arrays and that kind of stuff. So I think Julia will make you productive, so you get a lot of stuff done, but will give you all the beautiful stuff that you're used to as a systems programmer. You can write code native and you get to see the assembly. You can make sure that the SIMD instructions are being used the way you expect. And so as a systems programmer, you'll really like it because Julia is not opaque like Python. You can read the LLVM code, you can read the assembly code, and so you know what's going on. It's not like a black box. You can write C code and assembly code in line, and LLVM will just grab it in one pass. There's no overhead function calls when it gets compiled. So I think it's quite nice. I don't know how it is with Rust interoperability, but I imagine it's nice.
Awesome, awesome. Thank you so much.
One question, Robert. Okay, if someone wishes to choose open source as a career, one thing that comes into mind is what is the security of the job which you will be getting in future. So can you throw some light over how secure is the open source jobs?
Yeah. I wouldn't necessarily say that I wouldn't necessarily classify it as open source job or not. The thing is, no, I wouldn't classify it as an open source job or not. It's more like what ecosystem you're in. Are you in machine learning? Are you in big data? Are you in biology? And are you those kind of things? I think if you want to be writing open source software as a profession and then sort of contributing it out, you probably need to join a company that has an open source product. There are many such startups. A lot of them are in the US. One that I was working with recently that I think they're such a cool company is called Heavy.ai. They make a GPU database, and they recently open sourced it in its, no, not in its entirety. They're still keeping the secret sauce closed. Remember what I said about that? There's another company that I like more in that regard. Not necessarily they have a better product, but I think their approach is better, and that is ScyllaDB. ScyllaDB is a really cool NoSQL database like Cassandra, but it's written in C++ and it has a lot better concurrency stuff in it. But yeah, man, I mean, you would have to work at a company like that, and the competition is fierce. I think I think you're better off working with some open source tools and getting very good at them, and then trying to find a company that works with those tools. So for example, if you want to work with Apache tools, there's tons of companies that want to work with Apache's big data stacks, Apache Airflow, Apache Spark, all that kind of stuff. If you were to want to specialize in Julia, there's not a lot of companies that will pay you to write Julia and commit it back as your career. My company would. So maybe if you move here to Sweden, we could do that. But yeah, I don't know. I guess I wouldn't put all my eggs in one basket when it comes to just being an open source committer. You would have to get a job maybe at Red Hat, some of those types of companies. They're big companies, but yes, so spread your risk a little bit. Those yeah. You know what? Don't focus on the job. Focus on being really good.
Do we have any more questions? Um,
Hello, Robert. My name is Rishabh. Getting aside from all this technical stuff, we saw that you also have a lot of entrepreneurship skills. So, after seeing co-founders uh, Alexander Wang, who was a co-founder of Shape AI, getting successful, and many more. So, what are your views on startup opening in college or at a later stage in this industry of data, like
Yeah.
and AI, limited, like the related fields?
Okay. I my opinion is that you should start if you want to go that route and be entrepreneurial, do it as soon as you can. Once you have children and wives and husbands, you have a responsibility to take care of people, take care of your family. You can't afford to be out working at night and your child doesn't see you when they get up in the morning and doesn't see you when they go to bed at night. That's not okay. When you're young, when my wife and I were both working at Microsoft, we were even at the same office. We were there together until midnight. You know, days and days in a row together. Nobody thanked us for it, by the way. Don't waste your time at a big company working that hard. But as an entrepreneur, you can do that when you're young, before you have a family, and that's when I think you should do it, because you're the smartest, you have the most energy. What you don't have is the most experience, but that's easy to compensate for. So you need two things: you need to be smart and creative. That's one, and you need experience and a sense and a wisdom. So how do you get experience and wisdom when you're young? You get a mentor. There are a bunch of old people that are willing to mentor young people. It's a matter of pride for them. They're, oh, really? You think I'm wise? Well, actually, let me tell you. Make sure you get a good mentor though, because there are some that have been really lucky. Let me give you one example. We were looking for investors for. I was helping a friend get investment for his company, and one of the people that were there looking to invest was a guy that had gotten very rich off of soft drinks, sugar water. Man, there's like 100 people that launch sugar water drinks, and one of them succeeds. And it's luck of the draw. They all have marketing campaigns in it. That guy was really successful, and he thinks he's super successful because of what he did. If you're successful once, you're lucky. If you're successful 5 times in a row with all your companies, then there's something to it. So be a little bit aware when you're picking your mentor, but I think you can easily compensate for your lack of experience by picking 1, 2, even 3 mentors in different areas. Maybe a corporate manager that's high up, and just ask to meet them once a month or whatever. Find somebody that is in another field, marketing. Find another person that is a mentor that has run a startup, even a failed startup. Man, failing is not a bad thing when it comes to that. I've run 3 product startups, and I've helped friends run startups. Only one of the product startups was successful, and I think it was successful because of the stuff I learned from the first 2 product startups. I'm doing very well for myself right now, and it's because I've done it so fast, so many times. If you make it right on your first time, you're damn lucky. If you want to guarantee success for yourself, you have to do it over and over and over and over. Start early, get a mentor. That would be my advice. Many mentors, in fact.
So, in this regard, about mentors. So, I wanted to ask, like, how do you ask them basically? So, I have some mentors, but then I'm also like, it's difficult to get a good mentor, and how
Yeah,
do you develop a good relation with them, sort of?
yeah. I think mentors also want to feel like they're getting something back.
Yes, that's
So,
exactly.
I have even now I have some people that I try to meet on the regular, where there's no expectation of we're not doing business, we're just helping each other. So this mentor wants to get a little bit of insight into where technological trends are headed. This guy's an investor, the guy that I meet. And he is a very experienced real estate investor. He has been buying buildings, he's been buying woods and stuff like that. And I want to know how he moves. I want to know who he knows. I want to, and in exchange, I am basically the AI expert to end all AI experts. So sometimes he'll call me and he's like, "Hey, I heard of this company that's doing blockchain stuff. Is any of that true?" And he trusts me. And I'm like, "Yeah, it could be true, maybe." And he's like, "Cool. Can you look at this pitch deck?" And I'll give him some feedback. And he's like, "Cool, I trust you." And in exchange, I'll call him up and I'm like, "Okay, you know, I'm thinking about approaching these people. I Have you done that before? How do you negotiate a deal when the other people have this kind of leverage?" And he's like, "Oh man, I've done lots of negotiations like that. Look, what you're not supposed to. They have their position, you have yours, and you meet in the middle. That's not the way to negotiate. You need to start by building something that you both want, and then adding your terms onto that." And I'm like, "Okay, cool. That's genius. Of course, it's right." And so this guy gives me lots of advice like that, and it's a very mutual exchange in that way. So think of stuff that you can probably offer that person. Think different. So older mentors might be more open than you think if you just ask them straight out and say, I would like to so open up with what you're offering. I would like to tell you a little bit about the stuff that I'm working on, and hear a little bit, given your experience and wisdom, how you would approach some things, and just have a lunch once a month if that's okay with you, and then start off that way.
Yeah, similarly, I have a good relation with Johnny Chan right now, who's my mentor for the GSOC project. So I
Mm.
have developed that, over a long time, and it has been about, technical discussions and how we can grow that, slowly, and
Yeah.
what's the roadmap for us. So yeah, that has
But don't just go for technical mentors. So that's good. Like I said, you get like 3 mentors. You want a technical mentor, sure, somebody that's very inspirational, very good at tech stuff. I have some people like that. But get a business mentor. Get stuff, the stuff that you're not good at. You guys are obviously good at computers. You don't need people to inspire you there. You need mentors in other areas that doesn't come for free. That maybe a public speaking mentor. Something like that.
I think I could use that. So
Yeah.
I need to
Yeah.
develop it.
Speaking of finding mentors for stuff you're not good at. So like recently, me and my roommate, we started working on a blockchain startup, right?
Mm,
No prior experience on entrepreneurship and all. We both just tech guys, and
mm,
recently we just tried to break free of our comfort zone, and we went to this Web3 meetup,
mm.
right? Because they have been all over Twitter doing meetup. So
Yeah.
we went to one, and we met with this product manager who was at the top of the AR/VR game of our country. But then he
Mm,
took a sabbatical, and we were talking, and I felt like that I had nothing to offer, like nothing at all to offer. But for some reason, this guy, hitched up a convo with me, and we were talking. And later, he asked me to connect and all, and yeah, we did. But the thing is, like he also gave us advice about our business model and all. Okay,
mm,
all good. The thing is how to hit him back up, and
mhm.
how to keep it rolling, because sure, we did develop this rapport there, but I don't know how to keep it going, because I'm all as you say, we're all technical guys, and I have no skills about entrepreneurship, product management and all.
Mm.
So
Well, I mean, that's one thing that he's probably good at that you need help with.
yeah.
Ask for a recurring meeting. Ask for a lunch once a month that you pay for.
Hmm. That
Say,
seems
is
good.
it okay if I schedule you at the last Friday, the last Thursday of every month? I'll take you to my favorite restaurant or wherever. And I'm coming up with these business challenges that you've probably already gone through, and I just don't know how to tackle them. And I wanna share, what it's like for me, and hear, your feedback.
Yeah,
I'm doing a
that seems very
function
good.
now too, and the hard part is not the coding. It's tying it to a value proposition, figuring out how people are going to pay, all that kind of stuff.
Yeah, true.
Mm. I need to wrap up because I'm actually going to have a podcast in 30 minutes. Another one. I'm in a podcast room right now, in case you can't tell. But I think it's super fun and inspiring to be talking to you guys because I think you overestimate what you can do in 1 year and gravely underestimate what you can do in 10 years. And 10 years isn't even like the middle of your career. It's like just still in the beginning. So I think there are some hacks that you can use to increase your luck. You can do yourself a favor by getting a mentor and all that stuff. But if there's only one piece of advice I would give, it's focus on being really good at what you do and always be proud of the stuff you leave behind. Don't do half baked crap. Leave like good stuff after yourselves. That's what I would advise. And the good stuff will come by itself. And it's like working out. You're going to be disappointed because you're like, oh man, I didn't do anything after 1 year. But that's my point. It goes slowly. And when you look back 10 years, you're going to be like, damn, it's been I've come a long way.
It was great having you, Robert.
I appreciate being invited.
Can you share your podcast link? We might chime in.
Yeah, I'll share it. I'll go ahead. Let's see here. And where did we go?
Thanks, sir. Thank you so much.
I'll go ahead and share it here in the chat.
Also, you can tell us about what your podcast is all about, and
Oh,
all
it's
that.
not my podcast. Let's see. AI After Work, AIAW. It's a podcast that we do here in Sweden where I'm the host now. I went using computers. That I want to leave a better world for my son. I'm embarrassed of what we're leaving behind. I want to make it better. But there's a fun joke about is it easier to take a trained fighter and teach him how to act in order to make an action movie, or is it easier to take an actor and teach him how to throw a few good-looking punches? Well, you might have different opinions on that, but right now the same thing is sort of happening with computer engineers. Is it easier to teach a business manager principles of computer science, or is it easier to teach an engineer some business principles? And I'm leaning towards the idea that the people in this chat here, you guys are going to be called on to be business leaders because you understand AI and all this kind of stuff better than
business managers will ever be able to. So that's what the podcast is about, sort of discussing the crossroads of where we are now, where business is being forced to contend with the fact that AI is, changing everything.
Thank you for coming, Robert. It was a pleasure.
Thank you. I pasted the link here, and I will be seeing you in the ether.
Okay. Ta-da.
All right, everyone. Bye-bye.